Hi, I'm James McGuire, and today we're talking about graph database and graph analytics and how graph technology enables machine learning, among other things. To discuss that, I'm joined by Todd Blaschka, Chief Operating Officer and Chief Revenue Officer at TigerGraph. First, Todd, you are both of those things. Am I correct in thinking that?
That is right. I carry a lot of responsibility at the company.
They just let you do pretty much whatever you want over there, from what I understand.
I still have to answer to the CEO and the
Gotcha. So,
board.
uh,
There's still check and balances.
I'm glad to hear that. Very glad to hear that. All right, so let's talk about graph analytics and how is it different from other commonly used analytics platforms. And obviously, we're in a time period where data analytics is really exploding. So, what is the role of graph analytics in all that?
The role of graph analytics is all about identifying new patterns, finding
Hmm.
similarity within the data. And
Okay.
so oftentimes it's referred to as relationship analytics because you're looking for the connections and the meanings of the connection and how the data is related together. And
Okay.
this really goes back to, 40 years when the start of databases came. What everybody's trying to use databases for is to answer, to get answers of business questions out of the data. And so
Hmm.
they want to know how many times has James, gone and purchased something on Amazon in the last 30 days that was related to sunscreen, as an
Right.
example.
Right.
It's stored in many different silos of data. How do you link that together and then be able to provide a better recommendation to others like James, where James lives, that could also benefit from it? So it's all about finding the patterns and insight in the data that can offer better recommendations, as an example.
Well, I'm thinking about, a lot of analytics programs like, Tableau, for example, is going to give me those kind of relationships. Is that employing graph technology? Because I mean, they're going to give me relative relationships like that, correct?
Right. So Tableau is pulling data from relational databases, and
Okay.
TigerGraph integrates with it with Tableau. So users
Okay.
that also want to complement and add relationship analytics to what they are already getting through the value of Tableau pulling data in from a relational database can benefit from that because it can answer more questions or provide more insights on the data than what they can do traditionally with relational database backends.
Does that mean that if I get an answer from a data analytics platform that is relational by nature, how many times James searched for sunscreen as opposed to in contrast to what the entire population searched for, it is necessarily using graph technology, or can you do that without graph technology?
Well, you can. It's really, really difficult to do without graph technology. The
Okay.
reason why, it's how data is stored. So when you think about relational, think about something that you use every single day. Excel spreadsheets. You have
Right.
columns and rows. That's how data is traditionally stored as a transaction. It's facts. Information comes in.
Right.
But if I have information that's in my purchasing system, that's in my customer system, that has this information, how can I connect data from multiple systems to be able to link that data together to find new insights? And that is
Gotcha.
called in a technical term, it's called a join. You're joining tables.
Okay.
And relational databases are not designed to join tables. So the computation becomes very, very slow if it even ever comes back to answer that question. Graph databases stores it based on the relationship of the information. So you instead of looking at the facts of what was bought, you're looking at the relationship. Who's my customer? My customer is James. James then made this purchase of product A, and so now I'm looking at the relationship of the product to where it was shipped to other information about James that could then become more useful information that could find new patterns of how many other people like James also bought this product, because it's
Gotcha.
storing in different systems. And data warehouses still, still one of the storage tools. No company has everything stored in one system. So there may be many different systems. How do you link that data together? And that's where a graph database is designed, is to bring the relationship data and store it in a graph database so that you can run new algorithms to find patterns within that data.
Interesting. Really interesting. Okay. So, well, then, as long as we're going down that path, I know there is obviously that there's a graph database, as I think we've mentioned. Of course, we hear a lot about object storage, and is there any way to compare those two ideas to kind of help the understanding here, like object storage and using graph databases? Do those two ideas have any overlap at all?
There is very little overlap with object storage. Object
Okay.
storage is really just a way of storing the information, from the object format. But it's a matter of what do you want to do with that information. If you want to take the object storage and use that as a data source to go look for and identify patterns, to also predict better outcomes or be able to use to enhance your machine learning or AI applications, it can be part of one of the data sources to support the analysis.
Right. Interesting. Okay. Well, let's talk about how graph technology has evolved. I know the TigerGraph itself, from what I've read, it was founded in 2012. It got a big funding round in 2017. Correct me if I'm wrong on any of that, but if you can you talk a little bit about how graph technology has evolved through the years?
Absolutely. Believe it or not, graph database has been around for over 20 years.
Uh-huh.
Uh,
Okay.
and some of the very early technology, has been around in that area. So graph databases, when it comes into from a technical standpoint, and maybe this is just a good connecting of the storyline, is building a
Please.
relational database is a hard thing to do, especially that can scale, that can support big data. Building a graph database is much harder because there's a lot more computation you need to do on the data, crunching of the data, and that requires a lot of computational power in order to be able to find these insights, because these insights can have substantial impact on business decisions, but being able to go into the relationships. So about 20 years ago, graph databases started, and one of the early adopters is a company named Neo4j. And then
Uh-huh.
since then, there's been other technologies from Janus Graph and others that we really have called, more like, the generation one graph databases.
Okay.
They saw an opportunity where they wanted to provide a way for users to be able to interact with the relationship of the data. And then over time, and especially in the last 5 to 7 years, as big data and AI and machine learning have become, very big markets unto themselves, this
Right.
has really been where graph database has really taken on a new renaissance, because the companies that are building AI applications require patterns that can help train the machine learning models that can also then feed into AI applications. So it's because,
Right.
again, the common thing is around patterns,
Okay.
being able to find patterns, being able to find similarities. And so over the last 5 years, this whole movement and the entire graph industry has there's been over $500 million invested into graph technology companies just in the first 6 months of this year. So that
Wow.
gives a good indicator of the importance and the opportunity investors see in this market. And then with TigerGraph, we started in 2012. We were in
Right.
stealth mode for 5 years, building the database. Databases take about 8 years to be mature, to start the first
Hmm.
phase of maturity. And
Okay.
so then in 2017, we launched the company commercially. And then we have been growing at a very, very fast rate over the last 3 years, as we're hitting the tide where the market is connecting with digital transformation.
Hmm.
COVID changed a lot of buyer behavior, because with COVID, everything became distributed.
Right.
Now, when it becomes distributed, companies are asking the questions: what are my customers like now? Their behavior has
Hmm.
changed. They're not in office. How do I build and understand what my customers are, and how can I make those decisions very quickly to adapt? Because there's also startups that are developing new applications that I could lose the loyalty of my customer, because with 2 clicks on my phone, I could go from a neobank and sign up, and then all of a sudden a brick and mortar bank is losing customers. How do you
Right.
respond? Because your customer behavior is changing in real time. And that's where graph database is really well designed, because it can support real-time changes in data so that you can better predict behavior based on the information that's being processed in. So you're not having to wait 3 weeks or 4 weeks for data to get crunched on a relational database, because in 4 weeks, so much has changed in our lives. And especially with a company with data coming in from all these signals on a real-time basis.
And the reason that it's able to respond so quickly, as you're saying, is one of its qualities that it does really good work in terms of relations between metrics. Am I correct in thinking that?
That's right. It's the relation on the metrics. And one of the pieces with the database and with our database in particular, it's built, is built on a massive parallel processing framework, which means we can handle multiple actions at the same time. And what we can do is be able to run analytics as data streaming into a system. So here's an
Hmm.
example. If I'm going online to make a purchase, and I want to be able to finance the purchase. And so so when I enter my information as a user on a buyer's site, in
Right.
order to be given credit or buy now, pay later, or, which is a big trend right now,
Sure.
how do you run a credit check? And, the credit checks that people have been used to from the experience at FICO's, it's now changing. It's now also looking at social behavior, what other public information is available. So how do I pull this information from all these different sources to build a better profile in milliseconds to then say you are creditworthy, and now I'm going to connect you with this lender. And so
Hmm.
this is where Graph is well designed, because it's running that, it can run computations in real time on that data and then serve it up so that you can provide a very quick service to someone that wants to buy. Because if they
Hmm.
don't get that information in real time, the buyer can easily go to another website to make a purchase.
Right.
The
Right.
loyalty is so important. And so from customer acquisition to also then on the other side is, once they are a customer, how do I provide relevant product recommendation? And how many emails do you get each day that are generic and you look at and say, this doesn't relate to me?
Right. Right.
It's frustrating as an end user. Even my bank, the banks don't know if you have, a private banking account, a mortgage, a credit card line. It's because they're in three different business units.
Right.
So the relational world is storing as three different business units. Graph focuses on the user. So if the bank knows my relationship of having three different accounts in three different business units, now they can provide me a much higher level of service that's much more relevant to the relationship I have with the bank. That is
Hmm.
where Graph database is changing how companies are managing the relationships with their customers, their partners, or their suppliers.
Interesting. Well, I think you've touched on some use cases. I want to give you a chance to say any other use cases you think might be particularly enlightening in terms of what Graph is used for these days.
One of the ones I think that's most relevant right now is supply chain. We all
Hmm.
know about all these supply chain problems.
Right.
And one of our customers is Jaguar Land Rover.
Oh.
And Jaguar Land Rover has been using the technology for some time. And what they have done is been able to use the technology to make better decisions on their supply chain, on their supply and demand, to make it in real time as opposed to waiting for weeks. Here's the
Hmm.
example. Think about a car being nothing but parts, and
Right.
there's 4,000 parts in an average car. Those parts are provided by hundreds of suppliers. And then you need to be able to know where the suppliers are, what inventory do those suppliers have, and
Hmm.
then where is the demand for my car or the parts of my car, in what countries, in what states.
Right.
So if all of a sudden the demand for tow bars changes from California to New York, how quickly can I move that product over there so that I can meet that demand? And so Graph is ideal to be able to sync those areas up. One more great example I'll share is, and this is actually from one of the keynotes that will be speaking at Graph AI Summit,
Aha.
which will be October 5th in San Francisco. This is an open industry event where practitioners will come and present about Graph and AI and some of the use cases.
Hmm.
United Health Group, one of the largest healthcare organizations in the world, is
Sure.
using Graph to manage and track their member journey. Their members are the people that get insurance through United Health Group. So they
Right.
have 50 million different members, and to
Wow.
provide better quality of service when they're calling in, they're using a call center software that is powered by TigerGraph, that it allows them to be able to provide better recommendations on care of service, because they know all the information around their patients in one location, as opposed to having to pull from many different data silos.
Right, right. That's really fascinating. Okay. Uh, well, then I guess I would gather from all that graph is a fairly bright future. I mean, if you look ahead 2 to 4 years, I mean, what do you see in terms of where graph databases and graph analytics is going to be a few years in the future? And maybe
It
most important, how can companies prepare for that now?
Great question. I would in the next 4 years, I think there will be more understanding of just the word graph and what that
Right.
means. It's not it's not the chart you see in Tableau or what you create in Excel.
Right.
90% of the people don't understand it. And the fun fact is graph is actually based on a mathematical theory, which is over 200 years old. So
Oh.
it's a term that's been around, but for most of us, we're already consuming graph everywhere we are today. We just don't know it. From
Hmm.
when you are using Google to run searches on their website, to how you purchase, to better recommendations if you're watching a streaming service, and so on. So in the next 4 years, graph will, it's the fastest growing database category. It has been for some time, but it's
Huh.
crossing over into mainstream. And this will be one of the most important competitive advantages in organizations, because it's about how do I better know my customers and partners so that I can drive new revenue or save money. So I see in the next 4 years, the growth of graph being substantial. And it is not just me, it's the analysts.
What
Gartner
what is
has
the
identified
percentage now? If I could, like, percentage of data of graph databases has, like, what roughly percentage, amount of the market?
it's under 5% today,
Yeah,
but
so it's not
it's under
quite
five
all the
percent
way
of
mainstream
a
quite yet. Okay.
it's not mainstream yet.
Okay.
But it is moving in that direction at a very, very fast clip. It's
Mhm.
and what we're seeing, and even what Gartner, which has been following graph for many years, they've identified it as a top 10 trend in data analytics for the last 3 years.
Uh-huh.
And
Okay.
so they're also seeing it is foundational to AI and machine learning. So as not just a vendor that's presenting what graph technology can do, it's the analyst firm that are also guiding executives on how to find the better insights. Because at the end of the day, we want to ask business questions of our data, very common business logic questions. I want to know how many customers bought, bought this widget in the last 30 days and also bought widget B. Very simple question. Getting
Right.
that out of your database is a very hard task if the data is not connected together.
Huh.
And these are the pieces. So the business problems have always been there. It's a matter of educating the market on here's technology designed to help them answer those questions, and that other back-end databases like relational are not the right back-end for these specific use cases.
If it's given that the graph is hovering around 5% or under 5%, what do you think has held it back? I mean, we live in a world that is hungry for data and data analytics and databases of all kinds. So why
Yeah.
does graph have a smaller percentage?
It goes back to what I mentioned earlier, and this goes back to the engine, the ability to do the computation on the data.
Okay.
And most, the early generation graph databases are designed only to run on one machine. And
Uh-huh.
think about one machine meaning small data. So
Right.
enterprises have large data sets. And if they want to bring in data to look at patterns instead of 3 weeks worth of data, they want to look at a year's worth of data and then bring in data from other sources to enhance the to enhance that overall landscape, to ask better questions of the data. They need a
Right.
database that can scale, that can store. And
Hmm.
so this is where TigerGraph launched as a third generation graph database, where we are designed to be able to scale horizontally to handle large data sets. And that is
Gotcha.
what's held the customers back, is not being able to scale. And then second thing, not able to get the performance they need on the computation of the data. Because unlike relational databases, the computation that's needed to find these patterns, run these algorithms, is computation heavy. And having the right engine is what is allowing this to happen. So we're seeing customers, because technologies like ours is allowing customers that have been dabbling in graph in many pockets of the organization, but they haven't gone into production at scale because they haven't had a scalable system. So I think we're going to
Gotcha.
see more and more of this happen, not only from graph database vendors, but we're going to see this also coming in where other vendors, that have been in the market with databases, also start adding graph-like features, because it's all about asking better questions of your data.
Hmm. That's really interesting. Todd, that's neat. I'm going to look forward to the future of it, and I'm going to follow the market to be sure. I very much appreciate you sharing your expertise today. Thank you very much.
Thank you for having me, James. This was a great discussion, and I'll leave you with one thing to think about, and
Please.
this will be an earworm, and that's that
Oh,
you
good.
use graph every single day. LinkedIn is a graph.
Ah, okay.
So when you think of it's all about connecting and who's connected to who. Twitter is a social graph network. Facebook
Interesting.
is a graph. So when you think about it, next time you use one of those tools or look it up, you're going to realize you're already benefiting from graph. You just didn't know it. And each of those companies have built their own proprietary graph system. And so
Oh,
what TigerGraph is doing is building a system that can be used for enterprises to have and provide that kind of an experience of being able to get insight in the data and the relationship of the data the way you do when you're working in LinkedIn today.
cool. Well, I will keep an eye on the company for sure.
Yeah. Thank you, James. Thank you
All
very
right.
much.
Take care.
You too.